Okay, here are some notes and practice problems on Ohm's law. Ohm's law sums up what we already should kind of know about voltage, resistance, and current. And it is summarized as, well, Ohm's law is just V equals I times R. This is going to be one of our most important equations for DC circuits. That means if we have a greater voltage, we'll get more current, as long as our resistance is constant. If we have a greater resistance and we have a constant current, then we're going to get a greater voltage drop. That's a little bit rare, but we'll see that a little bit later. And if we have a greater resistance with a constant voltage, like the same battery, we will have less current. Ohm's law is true for any circuit element, and it's also true for the entire circuit. If we look at the total resistance of the circuit, the total voltage of the circuit, or the EMF, and the current that comes from the battery, or the total current, Ohm's law is still going to hold true. So let's just do a few practice problems in which we have to use Ohm's law to analyze a few circuits. First we have, find the current through this resistor. Well, we know that current is going to flow from the positive terminal of the battery around to the negative terminal. So it's going to go in that direction. It's going to be coming through this way. We know our voltage is 4 volts from our battery, which means we get lifted up 4 volts. We have to drop down 4 volts as we go across this resistor. So I'm going to label this minus plus 4.0 volts. And we're just going to use Ohm's law. Our givens are voltage equals 4.0 volts. Our resistance is equal to 12 ohms. And our equation is just V equals IR. We're going to solve for current, so that becomes I is equal to V over R. When we plug in our numbers, we get our voltage is 4.0 volts per 12 ohms. 12 ohms. 4 over 12 will give us a current of I is equal to 0.33 amperes. Pretty straightforward. V equals IR. I'm going to use blue for the next circuit. Next we need to find the resistance of this resistor. We're given the voltage of our circuit, or the EMF. So our voltage is 3.0 volts. 3.0 volts here means we drop 3.0 volts at our resistor as well. So 3.0 volts plus minus. And we also know that the current is the same as we go around the circuit. So the current through our resistor is also going to be 50 milliamps. So voltage is 3 volts. Current is equal to 50 milliamps. We're going to use V equals IR. V equals IR. This time we are solving for resistance, so we get R is equal to V divided by I. And that will give us R is equal to 3.0 volts divided by 50 milliamps, or 50 times 10 to the minus 3 amps. And that will give us a resistance of 60 ohms. There is our resistance. Question 3, we need to find the voltage drop across the resistor and the EMF of the battery. Now we know that the voltage drop across the resistor is going to have to be the same as the EMF of the battery. This lifts us up some voltage. We drop back down the same voltage as we go around. All we are given is the current running through this ammeter, and we're also given the resistance of this resistor, even though I just had to edit that in quickly. But we need those two to solve this problem. So how are we going to solve this? Well, I'm going to mark up our circuit. One, we know that current's going to be coming around here. That's our I. But we also know that the current is constant all around a circuit. So our current coming into our resistor is going to be 20 milliamps. We know there's 20 milliamps coming in. That's I. We know R. We can solve, or we should be able to solve, for the voltage across that resistor. So we know that resistance is 0.10 kilo ohms. We know that the current I is equal to 20 milliamps using V equals IR. We've already solved for V. V equals IR. We have 20 times 10 to the minus 3 amps times 0.10 times 10 to the 3 ohms. 10 to the 3 and 10 to the minus 3 are going to cancel, and we're going to be left with a voltage drop across that resistor of 20 times 0.1, which is just 2.0 volts. I'm going to fill that in my diagram in red. 2.0 volts, and since it's a voltage drop, I'm going to label plus minus here. It also asks us to find the EMF, but since we know that it's a 2-volt drop as we cross the whole circuit, it has to be a 2-volt EMF. So the EMF here is also just going to be 2.0 volts. And those are 3 problems solving Ohm's law for very simple circuits.